All right, good day everyone. It's test 3B review. Starting off with number 1, we see we have two different denominators, so we want to get the denominators to be the same. So we do that by multiplying each of the denominators by the other. So for example, x minus 7 here, I'm going to multiply top and bottom by x minus 2. Okay, and with the x minus 2, I'll multiply top and bottom by x minus 7. And therefore, the denominators are the same. And I can extend this out here to be x minus 2 times x minus 7. And then the top I'll simplify. So the first one here, I've got 2x squared minus 2x. Minus, is that right? 2x squared minus 4x. That's better. Then this is going to be a minus sign here, so I'm going to use this for the negative x times x in the second fraction. That's going to give me negative x squared, and then negative x times negative 7 is positive 7x. And now it's a matter of combining our like terms. So here I've got 2x squared minus x squared is x squared. And then this is negative 4x plus 7x is positive 3x. Then I look here and say, if I factor out this x, will I have an x minus 2 or an x minus 7? The answer is no. So this is my answer for number 1. Number 2, same idea. Here I want to get the denominators to be the same. So that means on the 6, I'm going to multiply. This is really 6 over 1, so I can multiply top and bottom by the x minus 2. X minus 2's. Okay, then as you can see, I have my x minus 2 for the denominator, since it's the same now. And then I'll simplify the top here. So this will be 5 plus 6x minus 12, doing the distributive property. So this simplifies here now. The numerator here is going to be 6x, and then 5 minus 12 is negative 7. And that's all I can do with that one. Okay, how about number 3 here? I got 2x squared, and this is x, so meaning what can I do to that x to make it a 2x squared? I can multiply it by 2x, and that'll be to the top and the bottom, the 2x. So I can see I have my denominator as 2x squared, and then what have I got up top? I've got this 5 plus 3 times 2x is 6x. Remember, I can't combine those, so it's 5 plus 6x. Or 6x plus 5, whatever. I can't factor anything out of it to simplify it any further, so that's my solution for number 3. Okay, for number 4, I see my denominators are opposites of each other. So therefore, to make these the same, I could multiply them by each other, but a little bit simpler way is to multiply the top and bottom here by negative 1. If I multiply negative 1 times 7 minus a, I end up with a minus 7. So what I do to the bottom, I do to the top. This negative 1 times 5 makes this negative 5. Okay, so negative, then I'll have my denominators the same as a minus 7, but then the top is going to be 5 minus 5, which is 0. And 0 over anything equals 0. All right, let's go on to number 5. Looks like a little bit larger of a problem, but we can do this. So our idea here is we want to get these denominators to be the same, but cannot do it this way, so we have to factor them. So when I factor this left side, it's going to be x. What is that going to be? That's going to be x plus 10 times x plus 2. Okay, and then the right side, the denominator can factor to be x, let's see, what would that be? X minus, or x plus 10 and x minus 2. Now we want to work on getting our denominators the same, so it looks like on the left side here I have to multiply top and bottom by x minus 2. I'll just throw it in over here, x minus 2. That makes my denominator the same as this one once I multiply this side by x plus 2. How's that? Okay, let me put my parentheses here. Okay, now I see my denominators are the same. And then I have to FOIL each of these separately and then combine my like terms. So let's work on that. Okay, so let me go down here a little bit. Oh, here I've got, what is that going to be? I'll bring it down here. It's going to be x squared minus 2x plus 4x minus 8. And then that's going to simplify to be x squared plus 2x minus 8. And that's going to be added to this fella here once I multiply it together, meaning the FOIL. And with that, I'm going to have x squared plus 2x plus 1x plus 2. And that's going to simplify to be x squared plus 3x plus 2. And now I get to add them together. So when I add them together, it's going to be what? 2x squared. I've got this 2x here with a 3x. That's going to be plus 5x. And then negative 8 plus 2 is negative 6. Okay, and that's all going to be over the x plus 10, x plus 2, and x minus 2. Then the question is, can I factor this? Can I factor this? Let's try. 2 times negative 6 is negative 12. What are two factors of negative 12 that add up to be 5? And there isn't any. There are no factors that will do that. Okay, so if I put 12 and 1, 4 and 3, nothing that will subtract to give me a positive 5 there. 6 and 2, so it doesn't work. So this, in essence, is our final answer. That was for number 5. Okay, for number 6 here, we've got a change in direction. We have to solve for x here. And the intro with the equal sign means I have to have an answer for x. A lot of times it's 2 answers for x. But the same process occurs here where I want to get my denominators to be the same. And remember, with the 1, it's really 1 over 1. That means we have to include the right side here to get to be the same denominator. So let's see. When I look at the x squared minus 9, we know that's x minus 3 times x plus 3. Okay, so therefore the first fraction here is missing the x minus 3. Okay, that's top and bottom. The second fraction's good to go, and this last fraction, the one on the right, the 1, I got to multiply top and bottom by x minus 3 times x plus 3. X plus 3 x minus 3. And now they're the same. I got them all to be the same. And now that they're the same in equations, I can drop those off because they would end up canceling out anyway if I multiplied by the LCD. And I'm just going to work on my numerator. So my numerator is going to be x minus 3 plus the 6. That equals this right side. And I know what that comes from. I'm multiplying it together. It's x squared minus 9. And now I'm looking at the x squared saying, it's quadratic. So I have to get quadratics equal to 0 to solve them. So I'll do that. So I got over here, I've got x plus 6 simplifying. And so I'll subtract x and subtract 6. So here's my subtraction of x. I'll put it here. And my subtraction of 6 is here. No, not 6. 6 minus 3 is 3. I just realized that. 3. And so I'm going to add 3. Sorry about that. Positive 3, I'm going to subtract 3. Well, I'm really butchering this one, but you know what I mean. So this is going to be minus 3. Plus 3 minus 3. I'll go like that. Okay, so now I'm straightened out right. So the left side is 0 equals x squared minus 12 and then minus x. But that's not in the quadratic form. It would be better if it's x squared minus x minus 12. Okay, and then what am I going to do? I'm going to take that and factor it. And that factorization is going to be x and x minus plus 4, 3. So it's equal to 0, so I got x will equal 4, or x can equal negative 3. Now I notice that if I plug in negative 3 in the original equation in the denominator, I'm going to end up with a 0 in the denominator. So I have to kick that one out. That one's not going to work, so I have one answer of x equals 4. Okay, and that is my solution for number 6. All right, number 7. Equation, denominator. When I have a situation like this, I can eliminate the fraction by multiplying everything by the LCD, or I can make the denominators the same, which I guess we should do. I've been doing it all along. So that means I have to multiply top and bottom by x. The middle one's okay, and the 6 I have to multiply top and bottom by x and over x. Denominators are the same, so I rewrite the numerator to be 2x minus 8 equals 6x. Looks like I'll subtract 2x from both sides. And what do you get? Negative 8 brought down, and this is going to be 4x. Divide by 4, both sides, so x equals negative 2. I can plug in negative 2 for any of my denominators, and I will not have a 0 in the denominator, so that means that is a answer. We have an answer for that problem. Okay, next problem. Okay, on this problem, it looks like I can do some solving of proportions. By the proportion method, I can cross multiply on this one or get the denominators to be the same. So when I see a setup like this where I have a term on each side of an equal sign, I'm thinking proportions and I can cross multiply. So this one I can look at as 5 times x minus 2. 5 times x minus 2. That equals this cross multiplication of x times x minus 6. There. This will work out fine. So when I go to solve for x, I'm going to have 5x minus 10 equals the right side of x squared minus 6x. I see the quadratic there, so I'm going to get it equal to 0 by subtracting 5x and adding 10 to both sides. Subtract 5x and add 10. So this is 0 equals x squared minus 11x plus 10. When I factor this, I get x and x minus minus, and what are my two numbers going to be? 10 and 1. So x will equal 10, or x can equal 1. Neither number will make a 0 in the denominator of the original equation, so that's a good answer, and we're on to number 9. All right, number 9. Get our denominators to be the same. Remember, the 6 is 6 over 1. Do that immediately so you don't forget the 6. I got some factoring to do here, what makes this a little easier. So if I take out the 2, I've got x minus 4. And now I can see I'm going to get my denominators the same a little easier by multiplying the first one by 2 over 2. First fraction when I'm speaking, when I say the first one. Second fraction we leave alone, and the right side, the 6 over 1, I'm going to multiply top and bottom by 2 times x minus 4. The whole thing, 2 times x minus 4. And now my denominators are the same, so I can concentrate on the numerators. And the numerators will get me, what, 2 times 4 is 8, plus this 4 I just bring down, and it's going to equal, let's see here, how do you do this? I do 6 times 2 is 12. Okay, then 12 times x is 12x, and 12 times negative 4 is negative 48. Okay, simplify everything. This is 8 plus 4 is 12 equals 12x minus 48. I'm solving for x here, so I'm going to do what? I'm going to add 48 to both sides since this 12x is already positive. So I end up with 60 equals 12x, and therefore x will equal 5. If I plug in 5 in the denominator here or here, then I can't use it, but I can use it because I will not have a 0 as a result of plugging it in. Done with number 9. Okay, here's our equation for the solving for the indicated variable. This gave us a little bit of a hard time, a lot of us, but here's how it works. So I'm solving for b, meaning getting b by itself. So in a case like this problem, I'm going to get rid of the fraction by multiplying the top and the bottom by, I'm going to multiply both sides by b plus e. b plus e. And over here, b plus e. Multiplying both sides by b plus e. All right, so the right side, these two cancel out, and I'm left with 2u. Okay, and the left side is going to be this t times b plus e. Okay, working on getting b by itself. So let's see, I got t times this, so I'm going to divide both sides by t to get rid of the t on the left side. And when I do that, the t's cancel out here, and I'm left with b plus e. That equals this 2u over t. Now I simply have to subtract the e from both sides. So b equals this here. Okay, very good. That was 10. Next. Oh, this one here, we're solving for g. Okay, so let's see if we're solving for g. I'm going to get all my denominators to be the same. So that means top and bottom here by g. Do it like that. All right, and then I notice the denominators are the same, so now I can solve for b. Let's see, what have I got? GB equals GR plus V. All right, I want to get my G's on the same side, so let's see. How about if I subtract GR from both sides? So that means these are unlike terms here, so this means GB minus GR equals V. And the key part in this problem of remembering what to do is to factor out the G. If I take out the G, I got B minus R left over, which equals the V. And now to get my G by itself, you can see I'm going to divide both sides by B minus R. So therefore, G equals, because the B minus R is cancel, of course, G equals V over B minus R. And that's number 11. All right, how about number 12? Let's see, I've got this equation. I see my denominators are y minus 4, so I'm missing the one in the middle here. It's over 1, right? So I'm going to multiply this 5 by y minus 4. And of course, as well as the bottom, just to see I got my denominators the same now. Okay, so that was easy enough. And so I can discount the denominator and simplify my numerator. So what have I got? I've got 4y, and this is going to be plus 5y minus 20, distributing the 5 to the y minus 4. That equals 5y. All right, so now I'll solve for y. So let's see, I can subtract 5y from both sides and add 20. I'll do it at the same time if you don't mind. So what happens here? I bring down my 4y. This is 0, this is 0, and it's going to equal, this is 0, and bring down my 20. 4y equals 20, divide both sides by the 4, so y equals 5. If I put that in the denominator, is there a problem with that? None. So that's my answer for number 12. All right, moving right along here. I've got number 13. Get my denominators all to be the same, so I'm targeting a 6x in each of them. So that means I have to multiply this 11 by 3 over 3, top and bottom. The 2/3 I'm going to multiply by 2x over 2x. And the 7 over 2x I'm going to multiply by 3 over 3. Okay, I can clearly see that my denominators are the same. So now my numerators are going to be simplified to be 3 times 11 is 33 plus 4x equals 21. If I subtract the 33, it's negative 12, that equals 4x. Divide by 4, so x equals negative 3. No danger of having a 0 in the denominator, so that's my solution for that one. Here I can, here I got that situation where I have an equal sign with a term on each side, so I could cross multiply here or get my denominators to be the same, but it would be easier if I cross multiply. So that would be 9 times 3x plus 2, which would give me 27x plus 18. Okay, and that's going to be equal to this 5 times 12, which is 60. Okay, and I'll solve for x. So here I'm going to subtract 18. So I got 27x that equals, let's see, was that 242. So when I divide by 27, both sides, I'm going to have that x equals 42 over 27, but I want to simplify that if I can. So let's see, 3 goes into 42 14 times, and 3 goes into 27 9 times. So that I'd have 14 over 9 would be my answer. Good enough? Good enough. Well, number 15 is a story problem about Harry can cut the lawn in 3 hours while his son Terry can cut it in 7 hours. How long would it take to cut the lawn working together? So our formula for that was, as you recall, is 1 over 3 hours for Harry, and then plus Terry, his son, can cut it in 7 hours, 1 over 7. You know, the dads can always cut it faster than the boys, the sons. And we want to know how long that'll take to do together. And there's our setup for this problem here. And we just solve for x. So same concept. I want to get the denominators to be the same, right? So that means I'm looking for 21x in each of them. And let's see, I'd multiply this by 7x over 7x, top and bottom. The middle one I'd multiply by 3x over 3x. That'll get me my 21x in the denominator. And then the third fraction here, it's 21 over 21. And I can see I got my 21x in that denominator. Alright, so my equation then becomes 7x plus 3x equals 21. And 7x and 3x is 10x, equaling the 21. Divide both sides by 10, so x equals 21 divided by 10, or the, what do they call that, mixed number, whatever that equivalent is 2. What is that, 10? I should know this. 10 into 21 is 2. 2 times 10 is 20, so there. Or 2 and 1/10 hours to cut it together. Okay, here in number 16, it's find the unknown length of the similar triangles. And as you recall, I set them up as proportions. For example, this left triangle, I'm looking at this as the fraction 9 over 16. And that's going to equal the right side, which is x over 24. And then I just cross multiply and whatever, divide. Yeah, I'm losing it here. Okay, so we've got this, so it's going to be 9 times 24 is, I don't care what it is really when I'm doing this, it's 9 times 24 equals 16x. 16 times x. 9 times 24, 16 times x. Okay, here's my 9 times 24 equals 16x. And now I'm going to divide both sides by 16. And this is why I don't want to multiply that together. I don't have to. So I know it's going to be x equals, and I'll simplify this. So what do we know? That 8 goes into 16 twice, and 8 goes into 24 3 times. So then I can see this is simplified to be 9 times 3 is 27 divided by 2. And that's this 2 here. And that's equal to, what was that, 13.5. Or 27 over 2, either one. Okay, number 16. Here's number 17. When Jack and Jill cut my lawn, it takes them 5 hours. Implying working together, it takes them 5 hours. When Jack works alone, it takes 7 hours. Find how long it takes Jill to cut the lawn alone. All right, so our setup is just slightly different from the first time we did the work problem. So this is going to be 1 over 5 plus 1 over x. Oh, no, take it back. This is 1 over 7. There, that's better. 1 over 7. It takes Jack. Then we want to find out how long it takes Jill working alone. That would be 1 over x. Because together they can cut it in 5 hours. And that would equal the 1 over 5. And using that same formula with a slight divergence to it will work. So here I want to get my denominators to be 35x. So I'm going to multiply top and bottom here by 5x. The middle by 35 over 35. And the right, or the 1/5, I'm going to multiply by 7x over 7x. Okay, denominators are the same. Simplify my numerators to be 5x plus 35. That equals 7x. All right, let's solve for x. So I'll subtract 5x. So 35 equals 2x. Divide by 2. And x equals 35 over 2, or 17.5 hours. So this one or this one doesn't, the same thing. 17.5 hours to cut the grass by herself. That was 17. Okay, number 18, complex fraction. We talked about this in class. Here's our fraction bar here. And we use it, it's like division. Keep, change, flip. Keep the top fraction, change the sign to multiplication, flip the bottom one to be 21 over 10xy. Okay, so this one's gone. Let's not get confused by that. And let's do our simplifying here. So what have I got? 5 goes into 5 once, 5 goes into 10 twice. I see an x here that I can scratch off, with an x here. There's cancel. And then I've got a 21 and a, well, this was a 2, so got to be careful. That's a 2, not here. All right, what else have I got? I've got 27 and 21, so 3 goes into 21 7 times, and 3 goes into 27 9 times. Okay, so that means I've got a final answer of 1 times 7 is 7 over 9 times 2y, and that would give me 18y. And that looks good as it is. All right, number 19. Okay, let's try this out, this complex fraction. So let's do the numerator separate from the denominator. So let's see here. I got 4 minus 11 over 12. Well, let's see. I can make my denominators the same by multiplying top and bottom by 12. of this multiplying times the 4 over 1. There's really a 1 there. All right, so that'll give me 48 minus 11. Okay, so what will that be? So let's see, I've got a 12 in the denominator, and I've got 48 minus 11, 7 and 3, 37 over 12, and that's going to be over 5 and 1 over 4, so let's make these denominators the same by multiplying the 5 by 4 over 4, and that'll give me what? 21, 20 plus 1 is 21 over 4. Okay, now I can do the keep, change, flip thing. It'll keep the top fraction multiplied to the flipping of the bottom one, which is 4 over 21. And let's just simplify this. So I got 4 goes into 4 once, 4 goes into 12 3 times. And it looks like that's all I can do. I have 37 over 63. All right, that's number 19. All right, here's number 20. Disregard this over here, please. I'm just finishing up here. All right, so here I've got something odd looking, but this is 4 over this bottom denominator here, and I'm going to simplify that by adding them together. So it looks like it could be what? I'll get my denominators to be the same, so it would be y over y for the first fraction, and then the second one, it's going to be x over x. Get my denominators to be the same. So then that would transform into, just the denominator now would be, here's my denominator, the fraction of the denominator, it's going to be xy is my denominator. Then when I add the numerators here, it's going to be y plus x. Y plus x. Okay, and then this 4 I could look at as 4 over 1. Okay, now I'm ready to keep, change, flip. So keep, change the sign, and flip this one. It's going to be xy over x plus y. Or y plus x. I can flip that around too if I want, and I did. Okay, so this is gone now. I flipped it, and this is my answer up here. 4xy over x plus y. And that is the solution. Okay. Thank you, thank you, thank you.